Hello everyone and welcome to another tutorial. So this is continuing on in our series on general tips and tricks. Today I'm just going to be doing a quick kind of tutorial on how to build an extensible class. So building classes is a whole topic in itself. There's books on it, and I'll be doing lots of other series just detailing it, but this will be a general overview of some of the tips and tricks that I use when I build my class, and specifically we'll be talking about how to build a very extensible class. So just first, a brief overview of what an extensible class is. An extensible class is usually, there's principles like solid development and all, but pretty much what you think about when you think about something being extensible, and it can be applied to more than just a class. It can be just whatever code that you write, a function can be extensible, but you think about it as being easily extensible. So everything you can add. Extensibility is just adding functionality to something. So even if we go to a real world example of something, if you take your car, a car is actually a beautiful, or most cars at least, are very beautiful examples of extensibility. You can give your car better oil, you can give your car better gas, you can change out components inside of your car, you can add lights onto your car, you can change out the LEDs in your car. All these things, you can extend the capabilities of your car. You can pull out the radio in some cars and add in another radio that has a lot more functionality to it. You can even do big overhauls, like pull out the engine, add more horsepower to it, tune your engine, do things that increase features of your car. So when we take that to our code, we can take it to just mean we want to make our code be a little more useful to us in some way. So if we have a previous piece of code that ideally it lives near this area of code that we want to affect, then we want to change that piece of code to enable us to do kind of some other task easier that we were doing that we maybe were not able to do before, or maybe it was just a lot harder to do that kind of thing. And oftentimes when you're coding, probably the number one thing that you're doing when you're coding is adding extensibility to your piece of code. You are adding new features to your code. So that is the core of what we do as software developers, is just add extensibility to a code base. The other thing that you're doing, as we've already discussed in other videos, is you're adding test cases, you're fixing bugs. So that's kind of examples of things where you're not adding extensibility. So you're improving the code, you're improving how something works, but you're maybe not actually, or you're shielding your code, you're preventing things from going wrong in the future, but you're not actually adding any features to the code. So you're not extending that code in any way. You're just protecting it or fixing something that was wrong about it. But when you're extending something, you're doing what's called adding a feature to your product. And so what we're just going to be talking about is what are kind of some safe practices, or how do you make it easy to extend your stuff in the future? Because some of the issues that you run into is that it's really, really hard to extend the code that you've already written. Maybe you don't have good test coverage to it. Maybe the code was really tightly bound and there's a lot of hard coded things inside of it. So just some general tips to make your life a little bit easier when you're coding out something. So I'm going to take and this is a huge topic, so do not expect me to cover everything in this video. I'll be making probably either a course, or I'm going to do a series for free on YouTube on this topic. So just kind of tag along on this one. This is just a general overview of some of the things I think are very important when you're kind of coding out a class, for instance, and just some things I kind of keep in mind as we code out something brand new. And like I say, I'm not going to cover every single thing that's going through my head, or that would go through my head on this, but this is just one example of how I might code out a class to make it something that's super extensible. So let's just kind of take, for example, diving in, we'll take, for example, that I'm building out some kind of game, or I'm about to build an API. And one of the first things that a game or an API backend would ever use is it might have a user case to it. So one of the first things that you might do when you're building an app for the first time is that you're going to have some user object, and you're going to need to manipulate that user object to do certain things. And that user object is going to store certain things like their name, their password, all these different things. And then you're going to need to be able to do actions against those things that you're storing. So for instance, if you're storing the name, then you need to have the ability to get that name from that user object. If you're storing a password, well, then maybe there's some challenge that you need to do before you can grab the password, or you just need to validate against that password. If it's a profile URL, maybe something is grabbing that URL, then going off to some CDN or a content distribution network to grab an image from that URL, and then it fetches that image and then serves it on the UI. So there's a lot of different things that your class can do. It can do all of that stuff for you and then feed that out to a UI. Or you can choose to kind of cut the line in certain places. And I'm just going to we're not going to go through just every single thing a user object might have, but I'll just show you some general examples. So here I am at the very beginning of a project. And like I say, the first thing that I don't have any code kind of in this code base. And I just say that the first thing I want to tackle is my user object. And I have a lot of options right before I go into this. And this is the complexity of coding, is you can go a lot of different ways. So I think the first thing we'll do is I'll just say that I'm going to make a class called user, and we'll just start from there. So I create this class called user, and me just diving right into it, I'm like, oh, okay. Well, a user, they have a username, and a user will have a password. And maybe I also will store their email. And that's it, right? And you're like, okay, cool. Then, and in the constructor, easy enough, I'll just pass all those values into the constructor. Yeah. And then all I'm going to do here is store the values from my constructor, or store the values that are being passed in from the constructor. Okay, easy enough. So here I have a user object now that I can call into, and I can manipulate it and do all kinds of stuff to it. If we want it to, so you have two options. I always say just go to a unit test. So I don't actually have a unit test project made just yet. Make a new project. I like to write all my code, test all my code inside a unit test. So general tips and tricks. Tests. Create that. Okay, cool. So I have my test here, and I have my unit test project right there, but I don't know why my computer's lagging right now. Let me just add a folder just for this unit test, extensible classes tests. And we will make a new one just for this one. So extensible classes unit tests. Okay, cool. Cool. So now I have my test project set up. I need to tell it that this is a test class. Darn it, I used the wrong thing. I don't want in unit. I think I wanted MS test. No, give me MS test. All right, let me go manage these. MS build. I want you. This is what I say. This is the most frustrating thing about C#. All right. MS test. Let's try. I may end up cutting all this out. We'll see. Accept that. But hey, just showing you all the stuff that you go through when you're deving out a project. It's good stuff to go through. Yeah, I mean, honestly, these tests aren't that different. So maybe I'll just try out this in-unit thing for this video. So it tells me that if I go up here, I actually don't even have to do it. That's actually nice. So I don't even have to decorate my class. All I have to do is go down to my methods, public void. We'll just make user test. And all I do is decorate it like that, and it should run. Cool. I wonder if that's gonna, wow, that plays nicely with the UI. Very cool. Alrighty, so I do my make user test, and so like I say, all I'm doing here, so what I do need to do is I need to add a reference to my general tips and tricks project. Okay, cool. So now all I'm gonna do here, what's in general tips and tricks? All I'm gonna do here is just make a user object, and I would never say to do tests like this because these are super fragile tests, and they're gonna always break because you're gonna change probably the constructor a lot over time. So try really hard not to make tests like this. And so here we're just gonna feed it in my username. Let's just say the password is this and my email is this. So we can already kind of see some things that we might want to do with our user object, some kind of features and functionalities that we might want to add to the user object just to make our lives easier with certain things, right? So especially validation. So you can imagine some user would pop in these strings for the username, and these might not be valid strings. For one, your password might not be plain text. Your username might have to follow certain formatting rules. Your email might have to also follow certain formatting rules. You might want to validate it somehow. So you can kind of see, okay, right away, there's a lot of functionality that we want our user object to be able to have. So before we kind of dive into that, I just kind of want to go back to the user object and just kind of note what all is happening already. So we're storing, so we already have a list of features that this user object is doing, even if we're not doing validation on all this stuff. So we kind of have a choice to make. We could do all this stuff inside the user object, or we could do it inside the user object. But note that the user object is already storing information. So that's, if we had a notepad to write down what exactly this thing is doing, it's storing information, right? First and foremost. Now, one of the number one rules I have in extensibility is make your thing, make your code as stupidly simple as possible, which means give it just one role. And I really hate for something to do a lot of different things. I don't like for my code to store certain objects, be the primary place of storage for certain objects, and then do a lot of operations on those objects, and then transform it, call it to another place, and then transform it some more. I do not like my stuff to do that. I think of it very much like organs within the body. Like it's almost stateless, right? Like if you look at your liver, your liver, I don't know that much about biology, but your liver is kind of filtering, is kind of one of the filters of your body. And so its job is not to really talk to the kidneys, even though the kidneys are a sort of filter as well. Your liver doesn't know much about the goings on of the kidney, as far as we know. Your liver is just kind of monitoring certain things in that come through it, right? It's monitoring the blood that comes through it, and then saying, okay, well, I'm going to do this when the blood contains this. I'm going to do this when the blood contains this. And it's adapting to the blood that comes to it. And then it ejects out whatever its job is. And then it says, okay, my job is done until the next load of blood comes back to me, right? So with this piece of code, we don't want it to necessarily be doing all these kinds of abstractions and stuff that other parts of the system should be taken care of. We want this object to, especially a class. A class to me is an organ. So we want this class to just manipulate the data in one way and then pass it on for us from here. So that would make me say, I don't want necessarily for my user object to be the thing that's validating the password, validating that the input password is correct. One thing I often see is that people will code the lookup logic inside of this user class. So let's just say there were some database that stored all these users in it. Someone might use the user class to look up that user in the database. I totally disagree with that. The user here, in fact, I would say that the user shouldn't even be storing this like right now its function has been served. It is storing data. So with that kind of in mind, right? So I've already listed that there are certain operations we would like to do on a user object. We might want to validate the email. We might want to validate the password. We might want to do, so there are things that we actually want to do against these values in this user object. But like I said, I want this user to be very simple and only do one thing. So without even moving forward, I'm actually going to simplify this down. So I'm just going to do a thing like this. And if you've seen my other video right here called Structing Data, you will see that I believe that structs are the red blood cells of a system, of a body. And they are the things that carry data through a system. So whenever you resolve that, oh, my class has the function of storing data, your instant reaction should be turn the class into a struct and then move all the functions outside of the struct. So without doing any piece of code change, we've now told the only code change that we did was change this class to a struct. We've told the person that all this thing is doing is storing data. It is not manipulating the data, and there's simple manipulations that you can do with data, and I'll discuss those in the future, inside of a struct. But we're not doing things like validating the email and validating the password and validating the username. We're not doing any of that stuff. We're not looking up anything. We're just storing the data. So that was a core function of a struct. Now, like I said, people will code in different ways. You'll see a lot of different code throughout your system, but this is one of my key rules of making extensible classes is keep everything simple and single function principle. So, and you won't always be able to do this, and sometimes you're moving quickly through a project. You just need to kind of get things moving. I understand you're not always going to follow this, but over time, as you think like this will be your immediate action is I'm storing data. Let's put that inside of a struct, and then let me operate on that data inside of a class. So now, like I said, now that we know that we're working from the data, and I have operations I would like to perform on this data, let's just take a random operation and move from there. So now I have this operation that's maybe this password. So right now the user object is storing this password and what we would call plain text. And what plain text means, for people that don't know, is it is just it is the password exactly as it's typed. So why that actually poses a big security concern, because if you store this password really anywhere in your program as plain text, then it allows someone else to come back later. So if some malicious agent is inside of your system and they see it in plain text, well, now they can grab that and use that somewhere else to access data that they shouldn't necessarily get access to. So usually you really don't ever want to reveal what a password is. You maybe just want to authenticate very quickly and just know that, okay, this person, this username is allowed to do this certain action. And that's what I care about. I care about their authentication. I don't necessarily care about their plain text password. So as you saw in this unit test, when I created this user object here, I just gave the user this password name, and I'll do a quick video in the future on just kind of how to go through the debugger. But if I run this test now, I think I have to build this project. I can just build you. I may have something broken. I'm just going to comment out this code from an old video. But if I look at this, let me just run those tests. I don't know why these tests are failing. Okay. Just run my test. I should be passing. Okay. Come down here and let's debug that test. Oops, that was the wrong one. Let me move here. Debug. Okay, cool. So I'm debugging. I'm now inside this user object, and here you can see. So now I have access to the values inside this user object because they are public, and I can see that the values that user object actually stored was the plain text of the email, the plain text of the password, and the plain text of the username. So I can see here that these are the values that I input into this user object, and those are the values that were actually stored inside of the user object in those field variables. Now, what I might say is that I never want to know what the password of the user is. So I always want it to be encrypted. I just want to know that. And then and for this is topics they get pretty complicated, but all I want to know is that the user is authenticated to do this action. And one of the ways that you can just say that, okay, a user is authenticated to do it, is if they pass some encryption test. So what people will do is, instead of storing the password, they will encrypt that password and then store whatever the encryption is of that password. And then when the user comes along with the password later and they just type that in, what they will do is test the encryption of that password and make sure that the encryption of that password equals the encryption that's stored in the database. And why that is so important is because it means that it's very, very hard to get to the encryption, whatever the encrypted value is of that password, without knowing what the actual password is. So a malicious agent might try to brute force and try to guess at what the password is. But with some of these encryption algorithms, it's projected that someone would have to brute force for many, many, many years, including just millennia, like the heat death of the universe would happen before they would actually crack the password through brute force. Now, there's a lot of other cool stuff that people can do, but for the intents of this video, what we're just going to say is that we don't ever want to store the plain text of this password. We don't ever want to pass it through our program, because all that does is it allows for someone to be able to store that value, and then next thing you know, man, like now someone's into your system because someone decided, I'm just going to store the password, I'm going to debug, and I'm going to print the username password out. And so what we want to do is we want to protect people in the future. So we're kind of coding with two intents, right? So we've coded up this user feature, and we know that it has very, very high privileged data, like a password in it. And so we want to prevent people from hurting themselves, from shooting themselves. So we don't ever want to store the password. We don't ever want it to be logged somewhere. We want to just keep this password encrypted at all times before we ever use it. So the first thing you might do, so like I said, this is a struct. Now, we don't want to put anything inside of a struct. So the first thing I might do, and I need to stop my debugger. The first thing I'm going to try to do is I have some options here. So I now need to be able to, I need to direct the program and tell it, hey, I need you to, I want to create this user object, but I need you to create it with this encrypted password key. So this password can never be revealed to people. And so you kind of have two options. The immediate option that someone's going to tell you, most people will go here and do, is they'll say, oh, well, the password, that password can never be known. Okay, cool. I'm going to come right here, and I'm just going to make, maybe I'll be smart. I'm going to make a private method and encrypt password. And, it's going to just, what I'm going to do here is I'll take it in as a password. I'll take that in as a key. Oops, actually, I need to return a string. And all I'm going to do is I'm going to return, let's see, password dot, what's so good? We'll just make up a silly kind of encryption. It's like, yeah, I'm trying to, like, it'd be nice to like swap them, like do a Caesar cipher on it maybe, but I don't feel like coding that out. So anyway, we'll just do this, right? So we're just gonna, this is the quote unquote encryption, is we just return the password in uppercase letters, and all I'm gonna do is I'm gonna just encrypt it. I'm gonna put it right here. Encrypt password. Oops. And just like that, I kind of, well, that's a funny one. We'll just say this. Okay, cool, because it's not doing anything to it. So I just say that. Okay, cool. That's fine, right? So if I go back to my test and I start debugging it, okay, if I go look at my user object, boom, the password has been encrypted, right? So I know that, and maybe I should have used a better one here or something, but who knows? Like, maybe I could have made all the S's stars or something. But it's like, okay, cool. So I know that at rest, my password has been encrypted. So I'm good. My work is done, right? Like, I don't need to worry about this anymore. So the reason that I don't like this is because we're now making our struct do something, right? We've now, and this is ugly. Like, because we couldn't have, the struct hadn't been created yet, so we had to make this method static, and then, which is a bad thing to do unnecessarily. Like, you don't, Like, what if this thing had to reach out to some other database to encrypt it, right? What if this had to make a class to encrypt it? It's like, okay, all these things kind of pose a problem with calling a function within the class. And then, okay, fine, I'll get around that. I'll make it, I'll pull this out of the class and I'll keep it static and stuff. But you see, you get that line of thinking because you're not keeping a clear line of function from with one piece of code. So like I said, the struct is never supposed to do anything to the object. It is just storing the object. So you can of course progress eventually with refactoring to pushing this code outside of the class and all of that, but let's just never reach that point in the first place. Let's just keep the struct saving the data. So when we push this code outside the class, and you can of course do this on your own, you can work out the equation for and like I said, I'll talk about this more extensibility kind of in future video series, but you can work out how pushing your code all the way outside the class eventually results in what? You just making a whole new brand new class, right? And this class is just going to be responsible for creating an encrypted user with a password. And there's actually a lot of fun ways that you can go about kind of implementing this, but we're going to go about it just the simplest way that I can think of right now. So like I said, we're just going to make a new class here. And actually, I think it would be better to make what's called a factory here. So create user. Now, a factory, for people that aren't familiar, is just, you can think about it as literally just what the name would imply, is its job is just to spit out users. So, or spit out just some object. So in our case, we are concerned with the scenario of creating the user. So we want to just create a user in the proper way. And this brings into kind of certain questions, like, should something else be able to create a user? So we're building this user factory here. So would it be weird for some other piece of code to create a user on its own? In my opinion, no. Like every that user object is defined to be what it is. If you want to lock down certain functionalities within that user, then you need to interface it and make sure it has those lockdowns in place. But because you've built that struct, because you've made this struct here, any piece of code is free to use this code in whatever way it wants. So just because we have a user factory here doesn't mean that user can only ever be created using the user factory. And I think that's another important way of thinking about when you're building a class, is that you want to limit the functionality as much as you can within that class, so that it's very clear that you're not supposed to do certain things with this piece of code, right? Because if you have something, so before we were able to always guarantee that this password would be encrypted, but maybe in some other parts of the program, that's not as important to have an encrypted password. So we are okay with having this user be have the capability of storing a plain text password. But if we weren't okay with that, then we would have to code this up a completely different way, and we would restrict it accordingly. So you wouldn't necessarily be able to give it a string data type for the password. You maybe give it a password data type. That would be another way of restricting this class to be exactly what you want. But we've said we are okay with this user having a string for a username, a string for a password, and a string for the email. We're just going to use a user factory over here to create the user exactly how we want. And this way of coding too is, I think, the most extensible way of coding is to accept one piece of code as what it is, and then adapting around that piece of code. So our user factory does not try to change the user object any. It just says that, well, to make the user object exactly how I want it to be, then I'm going to use this factory method. And so someone else can go create a factory method that creates the user exactly how it wants to be created, and they can all work in tandem and be totally fine. But we have created a user that we want. So out of this user factory, what I'm actually going to say here is I'm going to add on that it's an encrypted user. Encrypted user. So it's going to give a hint that something inside of it is encrypted. And I'll rename this file encrypted user. But I could just as easily come along later and create another factory that made a user in a completely different way. So just to reiterate, there are kind of two approaches that you can take. You can limit this data type to be exactly, to only ever have the abilities that it should have. And I agree with that principle. But when you're extending out, sometimes it's better to just accept the state of that user, of that object as what it is, and then build around it. Don't try to change the data type, just build it exactly how you want it to be. So that's kind of accepting the state of your class. So what I would tell the person that built this, I would say that if you never wanted, if you wanted this password to always be encrypted, I would have limited this data type, or I wouldn't have even passed in the password like this. Perhaps the only way to ever get to the password was to call it through a special constructor, or call it through a special getter method. Maybe this thing did define a special method that took in a secure string or something, which does combine data and function. But if that was the only way to get to the password, then that's just how that person would have coded it. So but assume sometimes that the class has already been coded, and then move on and just code around it. So and that, like I said, that allows you to adapt code that you've never written, and allows you to extend out and keep everything as free flowing as possible. Sometimes when we restrict things too much, it's very hard to code around it. So okay, out of the theory, so moving into building this factory. So like I say, all I want for this thing is I just want to give it a method, public user. I want to give it the create user method. So in here, in here we get to actually define out all the characteristics for how we might want to create a user. So so we know that our user it has to have a username, a password, and an email. So we might just pass those in here. So username, password, and an email. We'll pass those in to this function as just like this. And and this is free realm for you. Whatever you can make your factory method whatever you want. You can make a factory method that doesn't take anything, right? So you can overload this create user method, and just make it something like that, and just feed in random values. So fake user, password, and email. Right? So you can make whatever method that you want in here. And for this one, we just want to pass in the parameters. All right, now here's the magic. So like I said earlier, I wanted the password to be encrypted. So inside of this factory method, I kind of have an option. I can code the encryption logic in here, or I could call out to some other encryption engine. So let's just code it up in here. So public string encrypt. You can probably already guess what the right option is going to be. but string password. And what I really should have done is I should have just kept moving this function out. Anyway, that'll be an exercise for you. So this is almost the exact same password function that we coded up the last time, password.toUpper. Okay, cool. So now I have this encrypt password function. So before, it used to live inside of the user class, and it was called from the constructor, and it was a static method, and it was yucky. Now I've moved it into the encrypted user factory class, and all I now have to do is, and now I can use this. I can do an encrypt password. Oops. I can do that encrypt password. I don't really need this, but yeah, I can do an encrypt password just like that on the password. Doesn't need to be public, it can be private. So it's nothing outside of this factory is going to use it. And there you go. So if I come over here and so if I add a new class, and it's going to be a user factory test. Okay, so I come over here to my user factory test, and I just say it's a public void create user test. And I've got to inherit a whole bunch of stuff, or I've got to bring in a bunch of stuff. So using general tips and tricks, probably extensible classes. Okay, cool. And now I have to make the factory itself. So factory equals new encrypted user factory. It didn't take anything in, and now all I have to do is var user equals factory.create user, and I'll actually kind of show you what the differences are between these two. So var user2 equals factory.create. Ooh, I guess I misspelled something. Create user. So we want these overloaded. Okay. And so username, password, email. Oops. Add email. So that you can see the difference. Cool. So I'm going to put a breakpoint there. Yep. Just going to run these tests, make it pop up here. I could just build it, but and I probably didn't. Yep. That's what I get for trying to be clever. Oops. Look at that. Amateur hour. Okay. Build it. Okay, user factory. Debug. Okay. Cool. So if I look at this user object here, we can see that called the overloaded method here. Oops, user factory. So it called this overloaded method here, gave it the fake user password email, and if we look here, should match exactly fake user password email. Cool. So that's as we expected. If we come here, we would expect, okay, it was the email as we sent in, the username as we sent in, but the password has been encrypted, quote unquote, and manipulated. So that is as we expect. That was all lowercase, whereas the password that got stored was all, oops, the password that got stored was in all uppercase. So what we might kind of say from here, so yeah, all uppercase. So moving from here, we might say, okay, what's wrong with this? Like, I think we're good, right? Well, what happens if we have some other factory that wanted to create, to also create users inside of it? So, you know, maybe you have a video game that you're creating, and this video game is responsible for creating a whole bunch of users, and really, I shouldn't even say that. Let's just say that you there's a lot of, let's just, so in a general case, I like to kind of, you know, when you hear me kind of thinking, I like to think through just what exactly is, what would be the use case where you would actually need this. But it's also very easy to kind of talk abstractly about this. But essentially, what happens when you need to duplicate this functionality somewhere else? So an example of that is you subclass your user and you make like a different type of user. So, and this would be very common. So this is a very generic user, but let's just say that I come along and I make kind of an alter ego, and I make it very, very similar to user. So it's so similar that I in fact will subclass from user. So cool, struct. So, and it might is an interface list. Oh, okay. I shot myself in the foot by making that thing a struct. Okay, fine. I'm making it a class. Make a class for this example. Okay. So, why are you complaining about that? It's not an interface. Okay. See, once again, C# is not like other languages. It's a very particular language. Anyway, so let's just say then, fine, I'm going to jump past all this stuff, all that debugging, and say that it's a very similar setup object, just like username. So it stores a username. The work to make that code work was going to be completely kind of off the rails, so I didn't want to get onto that. So so here's the only other value that it adds. So like I say, in the what you would have actually done, you would have subclassed user, and then just added the secret name to this version of the user. But anyway, this is what it is, and it works almost exactly just like username. And yeah, you know, it would take username, email, and secret name. So like I say, it's like alter ego. It knows your real name, but it also knows your secret name. This in practice would be probably very bad to store anywhere, but hey, it is what it is. All right. Okay, cool. So alter ego works exactly the same way. And so what we come over here and do is we make an alter ego factory, because we have a very particular way that we want to code up our alter ego. So public, and we make them, so it's going to return an alter ego, and we have a create alter ego function. And just like before, so we're going to code the stupid use case, which is just return new alter ego. So Cool. So that's how this is going. And for structs, they have a default constructor that can take nothing, but we're going to actually feed in this username, password, email, and secret name. And actually, no, I'm going to actually okay, I'll keep that one. We'll code out the one that lets you pass in params as well. String, secret name. Okay. And so for this one, I'm actually going to do kind of, like I said, like maybe you never want to store what your secret name is in ever. You never want to store what it actually is. Like maybe that's only something that you can retrieve once you have the password and you like encrypt. You can encrypt the pass. Once you encrypt the password, it encrypts this or it decrypts the password. It decrypts the secret name as well. And that's the only time. It's like the place of operation is the only thing that can decrypt the secret name out of it. So you would have to have the key that you would get from decrypting the password. So so in that same vein, that means that we're going to actually end up encrypting both the password and the string, which is a totally okay thing to do. That's very common. So right then and there, you might already kind of catch the issue that we're having. So when we go down here, so like I said, we can pass in the username just fine, right? But right when I get to the password, I'm like, okay, I need to go down here and encrypt the password. So I do this public string encrypt password, and next thing I know, I'm coding the exact same function that I had in my encrypted user test. So, what can I do? I can make that static, and then I can make it public, and I can call the user factory method and then get access to it. I could inherit the encrypted user factory and then get access to this method that way, but I would argue that, we have violated the single function policy that I like to have for my classes, which is that this is a user factory. Its job is to create the user. Its job is not to encrypt passwords for the rest of the program. So this was totally fine to encrypt the password if it meant that I'm only encrypting the password for this single type of user. But its job is not to encrypt passwords for the alter ego. So what does that mean? Well, it means that we probably need to pull out this encrypt password code into its own class, and its own that class can be responsible for encrypting everything inside the system now, because then that becomes its job. Is just, okay, my job is the encryptor. So I make this class encryptor, and I'm being a little loosey-goosey. Well, okay, I won't be loosey-goosey. I'll just say that, okay, I have the string I will encrypt. So if you give me a string that is some source of data, then what I will do is I will return that data encrypted. And like I say, our encryption mechanism is just to bring it all to uppercase. Once again, just the world's worst encryption engine. So so what I do is so now I have this encryption engine, and so now I have this, so I'm going to go ahead and delete that out of there. And watch for this carefully. I'm going to take an encryptor into here. So let's actually examine why you might not do it this way. So one way that you might do it is you might just create an encryptor here. So encryptor, and then we just say encryptor dot encrypt password there. Oops. New encryptor. Cool. Takes nothing. I'm getting just a little bit of lag. There we go. And boom, right? We're done. Right? All's good, all's well, right? Well, we'll talk about this in the future, but you really never want to just create kind of new objects inside this class. Once again, your job as the class is not to kind of create things. Like this class, well, it's creating one thing, right? It's creating a user, but you're creating this new encryptor object as well, right? And while the encryptor object is something that is helpful to accomplish your goal, you're not really, you're still kind of violating the rule. It's kind of like, oh, you're hand wavy. You're violating the rule a little bit because you're creating all this other extra stuff to get to do your job. And the fact is that no, your job is to create a user. Like that's it. So creating a user can in itself be very involved and require a lot of different components. But you're not responsible for creating those components yourself. And I think it's called single responsibility principle. Yeah. So it's like, yeah, your job is not to create this thing, and you should try to never create big objects. So imagine this encryptor object actually had 100 different functions inside of it, and it did a lot of different stuff. So you don't really want to create something this powerful just willy-nilly, just out of the blue. So while you may need to be able to encrypt things on command, that's why you would actually store an encryptor, right? So you would store an encryptor here, and then you would pass it in through your constructor. Oops, here. Oops. So now something else is responsible for creating that encryptor for you, but you're never creating that encryptor yourself. So something else can pass you, and in the future we'll actually make this an inheritance, and I'll tell you why. And we'll make this an interface that we use instead of an actual very strict declaration, because we might not really care. There might be different types of encryption engines, and they might not inherit from class per se. They might inherit from an interface. So we'll talk about that in the future. But for now, you're just inheriting this class. So, and you're letting something else be responsible for creating the encryptor. Now, this doesn't mean that, I need to make a factory for making encrypted user factories. No, usually this just means that you need a builder outside somewhere, and that builder is the thing that's creating every single thing that all your factories are going to use. And so you would have this piece of code, and we'll actually kind of make it here. Oops. And we'll just call it builder, and we might leave the constructor empty, and it might define a method called build, and inside this method we might say that we want to make the encryptor here, and then we'll have our user factory equals new encrypted user factory, and it would take our encryptor here. Boom. And so just like that, right, now we've let this builder be responsible for building the encryptor. Now what does that mean? Because this encryptor, it's pretty stateless, doesn't rely on the state of other stuff outside of it. Why are you oops, I don't know why I'm forgetting this today, but anyway, that means that we can now reuse it. And where's the place that we're going to reuse it? You guessed it, it's going to be here. So this alter ego factory doesn't need to make its own function. It doesn't need to create its own encryptor. Instead, it just gets past the encryptor. So we'll say, encryptor here. It's pretty hard word to type. Encrypter, Encrypter, and twice Encrypter. Cool. So now we can come right here and we can say that, hey, I'm just going to use my encryptor on the password. I'm going to pass an email is fine, and I'm going to use my encryptor on the secret name. Cool. And just like that, you're done, right? So I can run this code, I guess. But here has just been a clean example of probably broke a test. Okay. Encrypted user, you need I don't have my builder code, but I'm just gonna make an encryptor here. This new encryptor, because I'm tired of spelling this. Okay, cool. Just like that, boom. And test probably passes, right? Are we building? Cool. We're building users as usual again. And what I'll do is I'll also add an encrypted user or alter ego into here. So I'm going to need an alter ego factory. Alter ego factory. This new alter ego factory, which also takes an encryptor. And I'm just going to say alter ego factory dot create alter ego. I'll make an empty one. Or alter ego 2 equals factory dot create alter ego, and I'll actually give it values. Yeah. Secret name. Okay, cool. So if we now debug this, now we can see that we want it. What we expect is for all this code to be the same, right? So when we create this user, we don't go through any of the encryption. So this all stays as we expect. But we go through the encryption engine on here, even though we passed a lowercase password, that was an uppercase. It had been uppercased, so it did go through the encryption engine. And then we go to alter ego. And alter ego had the email, the password. So, these were all things that we had hard coded in that default method for making alter ego. But here we can see that 2 things had gone through the encryption engine. So boom, there we go. So this was just a great example of kind of the single responsibility policy that you should try to apply to your code. So if you had gone and you had coded up this encrypted user factory by itself, and you had left that encryption code there, you might have thought that, oh, this is totally okay. Like, I'm building a user, so it's okay for me to just encrypt things here, just encrypt it inside the function. But as you saw, when someone else came later and they had their own factory that was spitting out anything that's encrypted, they had their own things to encrypt. Well, their options might have, if they were quickly going through this, they might have just publicly exposed the encrypt password method from the encrypted user factory, and then they would have called it inside of here, and that just would have been pretty messy because the encrypted user factory is not responsible for encrypting everything within the code. And so instead, what we said was we're just going to pull that encryption component out into its own class up here, and then we're going to let all other classes call into it so they can instantiate and create their own encryptor. They can instantiate and then use the encryptor method, or the encryption method that we have defined here. And we said that's not something that we want to define inside these factories, because these factories' jobs is only to create a user. Its job is not to create any other data types, absolutely no other data types, only the data type that we have for user, and we want only very user specific methods to be inside of the factory. So we said that we do not want to define the encryptor inside the factory. We want that to be something that's passed to us. So just like how the human body works, your liver, if your liver needs something from the heart, it's not going to create a heart and then use that heart to give it to funnel blood cells through it. It's going to demand something external to it, right? So your liver says, well, for me to work, I need a heart, right? And this is just like, you building a contract. This is actually what it actually is called, is kind of making contracts between things. And so your encrypted user factory says that before I do any work, I need an encryptor engine. And so that means that something else has to go provide it an encryptor engine or go build it, and then it will do its work. And then, so that's what we said up here. We had a builder, and the builder says, hey, this thing looks like it needs an encryptor. I have the perfect one for it. I'm going to feed that into it. So that's pretty much all I'm going to dive into on building extensible classes. Like I said, this is just a very general tips and tricks on it. A lot of stuff got covered in here, but there's actually a lot more stuff to talk about when building out stuff. But what we really drilled was just a single responsibility, and it can be very hard at first to realize how minute a responsibility is. So we started here at this class, and we were talking about all we wanted to do, right? All we wanted to do was make a user object with an encrypted password. That was it. Like, we probably also want to eventually do some validation on the email, maybe send a test email, confirm that this is the right email. We want to do that whole process flow. So, but we haven't even started something like that. So it tells you that there's a lot that goes into making very robust code that stands the test of time. While this might have taken, I think, an hour to kind of do this, eventually in the future, you can do this stuff in minutes because you know exactly where you're going. But, and this saves you hours of time down the line, hours and days of work, because you've followed single responsibility with this. Now you have a user class that you can just keep adding a whole bunch of stuff to, and you're not worried that you're going to break other pieces of code. Your user factory, which is responsible for creating the user, is the only thing that you have to really worry about breaking. But other than that, it's just storing data. You're not worried now that, oh, this thing was also encrypting the password and I need to pass an encryptor to build this user object. Well, where am I going to pass the encryptor in this param list? You're not worried about any of that stuff now. You're just saying this is a data storage container, and something else over here is going to create me. So some user factory is going to actually do all the work of creating me. All I have to do is worry about storing the proper type of data inside this object. So, and then like I said, when we pop over to the factory, all the factory has to worry about doing is creating the user, right? So it doesn't have to worry about deleting the user either, though it might, some might argue that a factory could be responsible for deleting a user and recycling it and all that. That depends. That maybe is arguable within the realm of responsibility. But the user factory's job is just, creating this user and making sure that it's usable as best as can. So, and don't take this as its job is only to create a user in a certain way. As we see here, we've defined two methods. So this one method is maybe a really easy method. I would be opposed to code like this. This probably wouldn't make it through PR for me. But if you need to get something going really quickly and you're just saying, hey, I know that a lot of these are going to be default values. I'm okay with everything being a default. I just kind of want to get a user created really quickly. And everybody has and this is an example of you have an app where everybody has kind of a default user profile. So everybody starts out the exact same, but then as they use the app, certain things kind of change about them. And so just them using the website is what defines their user account, not anything that they actually put in. And there's actually a lot of sites like that. Newspaper websites are just like that. So, that would be a good clean example of you would have a create user with no parameters, because all these are going to get defined over time. Or maybe this method would do a call to get your IP address from the request. And so that wouldn't be something that was passed in as a param. It's like something that would be available to it. Maybe up here, maybe the Encrypt User factory has access to some service that's able to grab IP addresses by default. Who knows? So, this is all just kind of an example of just keeping the responsibilities really, really small on it, and thinking a lot of your classes as your organs and your structs as the blood cells that flow through all the organs. And then, hooking everything up. Your veins are kind of the functions. So that's kind of all that I want to cover on that. That was longer than I expected. But that just kind of covers some kind of quick tips that I have on building out your classes so that it's super easy and extensible for me to come along and add stuff later and not be breaking a whole bunch of code. Like I say, I don't really want to be moving encryption code from, I might not have known about the encryption engine over in the Encrypted User factory, even though the name kind of gives you a hint. I might not have known that encryption code was there. And so I would have been building my own encryption engine when that code was always there. Whereas if there were examples of an encrypt method being called throughout your code, in this case is 3 places in the code, then I would have been like, okay, yeah, I can get behind. I can just reuse this component, right? Because it's all I have to do is go define a method over here. So really our builder would have also kind of had alter ego factory equals new. So all I have to do now is say, okay, well, my alter ego factory can also take that encryptor in, and now I'm off and flying, right? Because I'm able to just reuse the encryptor that someone else coded up for me in the future. So all I have to do is pass that in as my constructor. So yep. Anyway, that is it. Hopefully it was not too much rambling. There were a few snags we hit, but we made it through. We survived. So I will see you back next time for more tips and tricks. See ya.